Hey folks, so this is the third video in section 4.5, and these questions that we're going to be working on are all trigonometric questions. So the directions just tell me to find the indefinite integral. So let's go ahead. First thing is I don't love the way that this particular question was written. If it were me, I think that they should have put a set of parentheses around the 4x, but nonetheless, it does mean the same thing. So let's go ahead and make our u value then 4x. The derivative will be 4, and then our du will equal 4 dx, but I don't have any 4's in my question with the dx, so I'm going to go ahead and move that to the other side. So now let's start in on our substitution. So this piece here is going to get substituted by my u, so I'll have the sine of u. And then the only thing that's left is the dx piece, and so that piece is going to get substituted with 1/4 du. We'll go ahead and integrate. The integral of sine is negative cosine. And so then there's only one thing to do. We'll clean up a little bit and then substitute the x back in. So I have a negative 1/4 cosine of 4x plus the constant. Going to the next example, very similar here. We'll let the u equal x over 2. Notice that I wrote it as 1/2 x, just a little easier to think of it. So the derivative is going to be 1/2. I don't have any halves though, so I'm going to go ahead and rewrite, but also move that to 1/2 to the other side. Okay, so let's substitute in for this piece. Okay, so we're going to have a cosine squared of our u. And then the only thing that's left is the dx. And so we'll substitute in a 2 du. Of course, the 2 will go out to the front, the du out to the back. The integral of cosine squared is negative cotangent plus my constant. And then we'll put our x back in. So that'll be a negative 2 cotangent x over 2, or 1/2 x, either one, plus c. All right, number 44. I would say that the inside is going to be the x squared. Derivative is 2x. Move the dx over to the other side. Notice that I went ahead and moved the 2 because I need an x and a dx to be replaced. There's no extra 2 in there. All right, so we'll come over and start our substitution. The x and the dx piece is going to be replaced with a 1/2 du. And then just the x squared piece will get replaced by my u. So I have 1/2. The integral of sine is negative cosine. Don't forget your constant. And then plug your x's back in. So negative 1/2 cosine of x squared plus the constant. The next example, this one is a little strange. This one and the next one are both a little bit strange. It's a little hard to be able to tell what's on the inside and what's not on the inside. I went ahead and chose the tangent to be on the inside. I'll go ahead and let you in on a little secret as I was working through this. I did try to let secant or secant squared be on the inside, and it just didn't work out. So I went back to using the tangent on the inside. So our derivative is going to be secant squared, and then we'll move our dx over. I didn't have to do any manipulations there. So then the secant squared x dx is exactly the same as this, so it's going to just simply get replaced with my du. And then the square root of tangent is going to end up becoming the square root of u, or u to the 1/2 power. We'll find the integral, and that's going to be 2/3 u to the 3/2 plus the constant. The 2/3 I left it out front. The u, I went ahead and replaced my tangent x back in there, and it's being raised to the 3/2 power. Don't forget your constant. This particular answer is just fine, or you can also rewrite it. Notice that since this is a fractional power, it's the same thing as a square root cubed. So another way that you could write this is you could write the tangent of x underneath a square root and cube that tangent. Either one's an option. Doesn't really matter to me which one you choose to do. Now the next one actually has two different methods that we can use. So I'm going to do both of these methods because I just want you to understand that sometimes it's hard to tell what's how to go about a certain question, and you can do it multiple ways. So for this first one, I said that the inside was cosine of x, and the derivative is going to be the negative sine of x. And so then I went ahead and moved the dx, but then I didn't like the negative where it was, so I moved it over to the left. All right, so when we start our substitution, the sine x dx, which is this guy here on the top, all of that is going to be replaced with a negative du. And then down on the bottom, you've got your cosine cubed. So that's going to be a u cubed on the bottom, but written on top is going to be a u to the negative third power. All right, so we'll keep our negative out to the front. The integral of u to the negative third is negative 1/2 u to the negative second, plus your constant. The next step, I'm going to clean it up, but I'm also going to substitute back in my cosine of x. So the two negatives out front become positive. I'm just going to leave the 1 on top and the 2 on bottom. That u to the negative second, I'm going to go ahead and move it to the bottom and make it a u squared down on the bottom, but I'm going to plug back in my cosine. So that's going to be a cosine squared of x plus c. The nice thing about this is 1 over cosine is the same thing as secant. So I can write this as 1/2 secant squared plus c. Now let's take a look at method 2. So method number 1 is where I used the u value of cosine of x. Method number 2 is where I actually used some trigonometric identities. So the first thing I did, I didn't jump into u's right off the bat. The first thing I did is I split up my original. My first fraction was a sine over a cosine, and the second fraction was a 1 over cosine squared. Sine over cosine I rewrote as tangent, and 1 over cosine squared I rewrote as secant squared. Then I jumped into my u's, and I used u as secant of x. The derivative of secant is secant tangent. So hopefully you're starting to see how I'm going to work through this. So my du then is secant tangent dx. All right, so let's pick it apart then. So for my u, one of my secants is going to become my u. And for my du, the second secant and the rest of the tangent dx is going to be substituted. So I have a u and a du. That's all I have. So again, this is going to be one of the secants and the tangent, and this is going to be the other secant. All right, so when we integrate then, we're going to get our 1/2 u to the second power plus our constant. Plug back in, and we get 1/2 secant squared x plus our constant. It's the exact same answer as we got before. It was just two totally different ways of going about it. And we'll stop there for this particular video.